Okay, so let's look at question 14. Now, this is from your homework. So, what it says is on question 14, this is 1-1, write the statement in words and decide whether it's true or it's false. Okay, so how would we write this in words? Well, if I was going to write this in words, what would I say? I would say 2, right, divided by 5 is not equal to 3 divided by 10. So I'd write that as 2 divided by 5 is not equal to 3 divided by 10. And would that be true or would that be false now? Which one do you think? Well, this is not equal, okay? If it's an equal, they have to be the same. If it's not equal, they're different. So these are different, so it would be true, wouldn't it? But does everyone see what I would say if I was going to write this out in words? And you can use different words, but what I would say in terms of words, but I would just say 2 divided by 5, that's your fraction, is not equal to 3 divided by 10. And that's a true statement. And what about 15? Okay, I'll work out 15 for you here. Students sometimes get confused with the directions. All we want to do is rewrite it so the inequality symbol goes in the opposite direction. Now, right now, it's true because is 31 bigger than 10? Is 31 bigger than 10? Yes. Now, we want to write this in the opposite direction. So if I was to flip it around like that, and I flip my inequality symbol, I can't just write it as 31 and 10 anymore. Why not? Because if I look at it here this way, that's not true anymore, is it? Right? We want to make sure it stays true. So that wouldn't work. How would I write it correctly? Well, if I flip the inequality symbol, I need to flip the numbers as well to make it work. Right? Now if I flip the inequality symbol and I flip the numbers, is it true now? It is, isn't it? So I rewrote it where the inequality symbol was pointing the opposite direction. And when it pointed the opposite direction, I had to also do what? I had to also flip the order of the numbers. So that's what I want. So you flip the inequality symbol, and you have to flip the order. And that's what the directions want you to do. Rewrite it in the opposite order, opposite direction. Okay, and question 16. For which countries are the values not less than 14.7? Okay, now when it says not less, what does that actually mean? When it says not less, that means we can also look at it as what? Greater, can't we? Okay. So you would just look through the values here and find out which ones are greater than that 14.7. Or equal to, because it says not less, so it could include that. So we would want everything from 14.7 and above, because that's not less than that. And most of the others, I think you should be able to work through and figure out. They are, like 17, you've got to read it a bit, think about what it's asking. But I think this should help you get through that section 1-1 homework. Now we're going to move on, and we're now going to look at 1.2. And 1.2, we're going to talk about equations, expressions, and variables. So in 1.2, we're going to be talking about how to work with a variable. Now, variable is an unknown quantity, and that can be an x, that can be a p, that can be a q, some kind of letter or symbol that we use to represent an unknown part, or an unknown quantity. Now, we also need to know the difference between an equation and an expression. So let's start off with our basic definitions of an equation and an expression. So we'll start off with an expression. An expression has no equal sign. So an expression, it's going to have no equal sign. We looked at 1, with expressions. In 1, we never used an equation. We only used expressions. So an expression, it has no equal sign. And you can't actually solve an equation. What you can do is you can simplify it down. So these are examples of expressions. Five plus 9. Okay, that's an example, very simple one of an expression. 5 plus 9, that's an expression, no equal sign. Okay? And we can break this down, and what can we break down that 5 plus 9 into? Well, we can break that down into 14, right? Because 5 plus 9 is 14. Another one. Now this one's going to have a variable. Another example would be 5x minus 2. This is another example of expressions. These are expressions. So these are both expressions. Now, why can I not take the 5 minus the 2 and come up with 3x? Why can I not do that? Okay. Why can I not put this 5x and that minus 2 together? I can't do that because the 5 has an x with it, right? They have to be the same. So I cannot combine those together. We're going to learn more about that later on, but I can't put these together because they're different. So this has an x, this one does not. So they cannot be put together. Now let's do one where we can put them together. Here's another example. How about 8x minus 4x? Okay, so 8x minus 4x. Again, this is an expression. Right? And what can we do? Well, these are the same, right? These both have the variable x. Since they both have the variable x, we can put them together. And 8 minus 4 is a 4x. So you see how I can combine those together because they have x's, but this one, they can't be combined together because that 2 does not have an x. Are we okay with that? Do you see the difference? I know most of you understand that, but sometimes I still have students who see that and get in a hurry and try to combine them together. So those are examples of expressions. And again, in an expression, do not have an equal sign. An equation has an equal sign. So an equation equals something. And it can be solved. An equation has an equal sign. And we can solve it. So we're going to be learning how to solve these. So this has an equal sign, and we can solve it. Let's look at something that we can look at, and we can come up with our answer just by looking at it. Because we'll learn the techniques to actually solve these later on. But right now, this is an example of an equation. Now, we're not using any techniques to solve it, but can someone tell me what they think x would be? 2. How did you come up with that? Well, 5 times some number gives you what? 10. And of course, now 5 times 2 is going to be what? 10. So this is why this is an equation. It has an equal sign. So equations have an equal sign, and it's an equation because of that equal sign, and we can solve it. Now, we do not have the techniques to solve this yet, so on these, you're going to be given an equation, and you're going to be given some numbers to check, to try to figure out which one of the numbers works. Okay, so now let's work through a couple of these. We're going to learn how to plug numbers in, and then we're going to learn how to check and figure out which value works. So let's look at a couple of these. We're going to learn just how to plug in numbers. These are going to be expressions first, and I'm on page 41. And we're going to begin with, well, let's do a fraction one. How about we look at 31? Well, actually, let's start with how about question 30, just to make sure we understand fractions completely. We're going to do a lot of these with fractions, so let's actually start with 30. Sorry about that. I think 30 will work out better for what we need to do here. And this one's very easy to work with. We're only going to do part A. So only work out part A. And if we read the directions here, it gives you the values they want you to use. So they want you to evaluate down this expression. And we're going to use x equals 2. And we're also going to use y equals 1. And this one's really, really easy to work with. Just to make sure we understand fractions, very simple on this one. Plug in our values. Okay, so we're going to plug them in. So when we look at this, this is an expression, no equal sign. We've got the values. We're going to plug our values that are provided in. So plug in that 1 for y. And then I plug in that 2 for x now. Okay, so I just plugged in the values that they gave you. And now we can reduce it. Well, 8 divided by 2 is 4. Order of operations, addition goes at the end. Multiplication, divisions first. And now we have 1 plus 4. And 1 plus 4, what does that give you for your answer? 5. So what would your answer now be? 5. That's it. And this again is an example of an expression. Okay, and that was question number 30. That one had some fractions in it. Okay, let's look at 32. 32 is going to make us get a common denominator again. We did these before break. Let's make sure we remember how these are done. And again, we're only going to do part A. X is 2. Y is 1. So what are we trying to do here? We're going to plug these values in. We're going to see what we've got, and we're going to reduce it down and simplify it. We can't solve it because we're not going to have an x left over. Numbers are going, or the variables are going to be taken care of with numbers. So plug our values in. So that is then 2/5 plus 1/4. Now, if I want to add these together, I have to have a common denominator, don't I? Okay, so least common denominator of 5 and 4. That's going to be 20. How did I come up with 20? Well, 5 times 1 does not go into 4. 5 times 2 is 10. Does that go into 4? No. 5 times 3 is 15. Doesn't go into 4. 5 times 4 is what? 20. And that 20 goes into 4. Right? 5 times. So it works. Now let's go ahead and get ready to combine. We need 20s down below. So 5 times what makes it 20? 4. So we need a 4/4 here. And 4 times what makes it 20? 5 over 5. Okay? Now we've got 4 times 2 is an 8. 4 times 5 is a 20. 5 times 1 is a 5. 4 times 5 is a 20. We add those together, and 5 plus 8 makes it a 13 over 20. And there's your answer. I just wanted to pick another fraction one just to make sure we see how they're working. Right, let's try now the one with exponents. 38. So we're going to look at question 38 next. Again, we're only doing part A. And we're only going to be doing part A. And we've got x is 20 and y is 1 here. So we'll plug our values in, simplify it down, and see what we've got. Okay, so let's go ahead and work through this one. Plug your values in. So we've got 1 squared plus 1 over 4 times 2 plus 5 times 1. And this one's actually easier than what we did in the last section. So let's go ahead now and break it down. And you can do this all in one step if you want, or you can split it up. I'm going to go ahead and split it up. I think it's easier. I think there's enough to warrant breaking it into pieces, chunking it out. So let's look at the numerator. And in our numerator, we have 1 squared plus 1. Very simple on this one. Wait, did I plug the right numbers in? Oh, should be it. Did I mix them up? Let's see. X is 2. So that should be 2. Shouldn't, my mistake there. Sorry about that. Sorry about that. I didn't even realize it until I went back and looked. And it happened, so now hopefully we're on the right track. Sorry about that. Yes, we plugged the 2 in, not the 1. All right. So now that's 2 squared. Because I thought something didn't look right when I looked at it again. So now we've got 2 squared. We do our exponents first. So 2 squared is 2 times 2, which is 4. And 4 plus 1 is now a 5. So there's that piece. And if I make a mistake or something doesn't look right, make sure and say something. Try not to make mistakes, but once in a while it happens, just like you do. Okay, now what about the denominator? Well, in our denominator, we've got 4 times 2 plus 5 times 1. Multiply first, so 4 times 2 is an 8. 5 times 1 is a 5, and that makes it now 13. And so that breaks down when we plug our values in to be 5 over 13. Right? What we're going to be learning about next is we're going to be talking about how to take words and transform these words into a mathematical expression that we can break down. So let's start with our operations and talk about what terms go with each operation. So we're going to look at our operations. And what words can we associate with a plus? Well, we can associate that plus sign. We can associate that with a plus. Add. Okay. So plus, add, sometimes you'll say combine together. Those all mean addition. You have a minus sign, that's subtraction. Sometimes we say minus. What about divide? Okay, divide, we can say divide. Or you can also use the word quotient. Okay, because quotient also means divide. So we're just learning about our operations and what goes with these operations. So when it says plus, that means addition. Same thing with add. Subtraction is minus. Same thing. Divide. Quotient also means divide. What about multiplication? When we talk about multiplication, we can multiply. So that means multiplication. And that's about the only one for it. So we're going to be using these terms here. Oh, and times. Don't forget about times here. Times also means multiply. So multiply and times both mean the same thing. Okay, now let's look at some of these. And we're going to try to take these verbal expressions or verbal sentences and rewrite them into expressions and clean them up. We're going to use x as the variable. So I'll put question 45 on the screen. And we're going to look at how to rewrite 45. Now, when we talk about subtraction, we have to make sure we got the correct order. Addition order doesn't matter, but subtraction order matters. So let's try to figure out question 45. And when it says a number, we use the variable x to represent that. So 2 is subtracted from a number. 2 is going to be subtracted from a number. So I'm going to write up two options, and you're going to tell me which one you think is correct, and then we'll talk about why one of them is correct and one of them is not. So here's your two options. Okay, let's talk about these. One of them is correct, one of them is not. I think that is the incorrect one, the bottom one. Why? With subtraction, you have to make sure you watch the order. Order is very, very important. Okay, so let's go back and read question 45. 2 subtracted from a number. So that means that 2 is being taken away. And so that 2 is going to be on the end. So 2 taken away from a number would be what? Would be this one. Because the 2 is being taken away, so it's put on the end, right? Like if I have $12 in my bank account, and well, let's just use a number so we can see 2 subtracted from 12, okay? 2 subtracted from 12. You would put your $12 in your bank account first, and you would take out 2 at the end, right? That gives you 10. Make sure you get them in the correct order. So when you say subtract and take away, that number goes on the end because it's being removed at the end. So make sure they go in the correct order. So that's why it's x minus 2, not 2 minus x. Does that make sense? Okay? When you subtract, you put it at the end because order matters with subtraction. Let's look now at how about question 50. So I'll put question 50 up on the screen so we can read it. And then we'll come up with our answer. So question 50. Same type of thing. The difference. Okay, so what does difference mean? Difference means subtract. So the difference of 8 and a number. Okay, so what are we doing? We're taking 8 away from that number, right? 8's being taken off. So 8's going to be on the end. So how would I write that in the correct way? Well, sorry, make sure we got it right. Difference, make sure we don't mix up the order here. I wasn't thinking I said it wrong. The difference of 8 and a number. So we're subtracting. We're taking 8 and we're doing what? Difference from the number. So that would be 8 minus what? 8 minus x there, right? Because you have to be very careful with the wording. When it's subtracted, you have to make sure it's on the end. When we just look at difference, we're just subtracting. So be very careful with subtraction. Okay, and one more of these, 54. So we're going to look now at question 54. The product of 9 and 5 more than a number. Now we have to make sure we understand what all the pieces are doing. So when we look at this, we see product. Now what does product mean? Product means multiply, right? Okay, so that's the first piece. So that 9 is going to be the product here. And what are we multiplying that 9 by? We're multiplying that 9 by, and it separates it with the and, 5 more than a number. So 9 is the first piece. And then we use parentheses. And then we're going to put inside the parentheses 5 more than a number. So that's going to be 5 plus x. So we've got a 9 out in front. That and separates the two parts, and that's our multiplication. And then we have the number plus 5. Now, on this one, I can either write 5 plus x or x plus 5. It doesn't matter. With addition, order does not matter. It's irrelevant. Subtraction, though, order matters. Multiplication, same thing. Order does not matter at all. Division, though, it does. So be very careful with subtraction. Make sure they're in the correct order. When it's adding, you can write them in any order that you want, because it's all commutative. It all goes the same way. We'll learn about our properties later on. That's in a later section. Now let's look at some equations. Now, when we talk about equations, they're going to have an equal sign. So we'll look now at question, how about we look at question 70. Now this one is going to be an equation. And what's the difference between an equation and an expression? Well, an equation is going to have an equal sign. So we're going to have an equal sign. And we're going to be able to solve it. So we're going to be able to get a number on this one. So we're going to look at question 70. The product of a number and 3 is 6. Now, that's going to represent our equal sign. So is means equal. So when I look at this one, the product means multiply. So the product of a number and 3. Product of a number and 3. Product again means multiply. So that would be 3x. 3 in a number. Okay, that gives you the 3x there. Is, remember, is means equals. And what does that equal? That equals 6. Now they give you different values, and we need to figure out which one of these works. We want to find the solution. These are our possible answers. So these are going to be our possible answers. For all these questions, you have these numbers to choose from. And we need to figure out which one's going to work. Now, you can look at it and you can tell. So we want to figure out which one's going to work. Let's see which ones don't work. 4. Why does 4 not work? Well, if I plug in the 4, 3 times 4 would make it what? 12. Does 12 equal 6? Nope. 6 doesn't work because 3 times 6 is 18. Doesn't equal the 6 there. But what does work? 2. Because if I plug in x equals 2, and these are the only numbers that we can choose from. If we plug in x equals 2, that'll work. And why will that work? Because if we go to check it, see, we get 3 times 2. And that gives you 6. And the sides have to match up. So we went through and we made sure that our signs matched up. No, the sides match up. Sorry about that. So always make sure that those sides do match up there. And now we'll move on to a couple more complicated ones, and then we'll take a short break. I like to take a break after about 45 minutes of lecture because it's hard to really sit for more than about half hour. We've got 3-hour blocks. I like to give you a couple of breaks. So about 45 minutes or thereabout, we'll take a break. So work out a couple more of these, and then we'll take a short, quick 10-minute break again. So let's look at, how about 72? Okay, so we're going to look now at question 72. Let's see what we've got here. I picked 72 because 72, we've got a fraction involved, maybe. Okay, so for question 72, we need to come up with our equation and then figure out which number is going to work. This one has a fraction, so the sum means add, so the sum of 6/5 of a number, and 2 is 14. Okay, let's focus on this 6/5 of a number. Well, 6/5 of a number, that would be 6/5 x. So that's going to be our first part here. That's going to be your 6/5 x. We got our 6/5 x there. Now, what are we doing with that 6/5? It says the sum means add, so the sum of 6/5 of a number and 2. So we're going to add 2 to that. Is everyone okay with how I did that? Because we do the 6/5 x first, and then we're going to add 2 to that. Then we have the is, and what does that is means? Okay. Is means equals, right? Is means equals, so that's going to equal now what? 14. Okay, let's check our numbers out. We've got 2, 4, 6, 8, and 10 to choose from. We want to figure out which one is going to be our correct solution. Okay, well, we can plug them in and see. So let's just check each one until we find it. 2. Now, we do not have to break them completely down. All we need to do is to get to the point where we can say, are the sides the same, yes or no? So we're not going to have to break it all the way down. We're not really going to have to combine fractions. We just need to be able to look at it and say, do these sides look like they could be the same, yes or no? Well, this is not going to work. How do I handle this 2? When I plug in this 2, that 2 is actually a 2 over 1. Okay, so I put the 1 there. 6 times 2, well, 6 times 2 makes it 12. 5 times 1 is 5. That's not going to work. I don't have to break down that fraction. I don't have to do anything else. Why can I say that the sides aren't going to match? I can look at it and say there's no way the sides are going to match because this one has a fraction, right? This one does not. So this side has a fraction, this side does not, so it's never going to work. So that one's not going to work. So 2 is not a solution. So we'll cross that one out. What about 4? Let's see if 4 is going to work. And I'll write that as 4 over 1 here. And 4 is not going to work either, because 6 times 4, well, 6 times 4 is that 24. And that's not going to work. Why is that not going to work? Because what do we have on the left-hand side? Fraction. Do we have a fraction on the right-hand side? No. Now let's check the one that does work. So there's only one that's going to work. And once you find it, you can stop. We could go ahead and check the 6 and the 8 and the 10. But 10 is going to work. Now, why is 10 going to work? Let's see why 10 actually is our solution here. And when we talk about solutions, that just means the sides are the same. So we need to make sure that the sides are the same. What's going to happen here? Well, we are multiplying, so when we multiply, we can go ahead and cross cancel. So I can take that 10 and that 5, and I can reduce that down to a 2 and a 1, right? Because 5 and 10 both have a 5 in common. Now look at what's going to happen. 6 times 2 is 12. 1 times 1 is 1. And what do we know about 12 over 1? Well, 12 over 1 is the same thing as 12. And now we know it works because 12 plus 2 is 14. And the sides are the same, so it works. So we now know that our solution, the only number that fits this criteria, is going to be what? It's going to be x equals 10. Now, save yourself some time and don't work these all the way out. When you're checking them, if you can tell already that the left has a fraction, the right side does not, you know it's not going to work. You don't have to break them down anymore. Once you get to the point where you can clearly tell that either there's no way to work or it will, that's it. So like this one, we got to this point, it still had the 5th. We knew it doesn't work. Same thing with the 4th, doesn't work. But when we tried the 10, 10 broke down and 10 actually did work. Okay, let's see. I think we'll go ahead and take a short break. We've worked through quite a bit, and that should be most of 1, 2. So let's take a short break, and let's meet back here at, how about 10:30? So let's meet back here at 10:30, so about 10 minutes. We'll come back, and then we'll finish up if we need to 1, 2 when we look at some of the homework, and then work through 1, 3.